we can look up at the sky and see the stars and nebulas and other galaxies with a telescope and be excited by the strange, interesting patterns the universe forms. And we can also look in the other direction, down towards the small, and see new and strange and exciting patterns that are formed by these pieces of the universe that we're all made out of.
You know, we're trying to make a movie using atoms, and so that sounds like a simple concept, but in reality, of course, these atoms, it does take some concentration because you want to get them in exactly the right spot. We have a tool that allows us to move atoms on surfaces and build structures one atom at a time, and we want to explore how can we use atoms on surfaces to do computation and data storage.
I thought when I first heard that we're gonna make a movie out of atoms, I thought that's crazy. I was worried that it would be a lot of work moving these atoms, and we've started making some of the frames. It's kind of cool, and it's addictive.
All the action of our movie, our little guy made out of atoms, is going to be right on top of one of these surfaces. So to make this animation, we move molecules around one at a time to draw a little picture. And we save that picture and move on to the next frame to start to tell a story.
This is a very challenging task because nobody, as far as we know, including ourselves, has ever moved 5,000 atoms.
Now we see the man that's built with all these carbon monoxide molecules, and then some of them we would have to shovel away to make it really be the movie frame, so we would have to clean up a little bit.
When we see the image in the microscope, we see it magnified about 100 million times. If an atom was the size of an orange, then the orange would be the size of the whole planet Earth.
What we have been doing for the last 40 years is we've taken essentially the same silicon transistor and we scaled it down, putting correspondingly more transistors on the same chip. Very recently what we have done is we've been interested in the magnetic properties of atoms on surfaces. And really what we wanted to answer is a very simple question. How small can you make a magnet and still use it for data storage?
We know that we can make it stably out of 1 million atoms because that's what's done in current technologies. And we found that for the materials that we chose and that we're able to work with, only 12 atoms is sufficient.
You could carry around not just, 2 movies on your iPhone or something. You could carry around any movie that was ever produced, basically. We're using 2 scanning tunneling microscopes to make this movie. First, we need to look at the surface and we need to figure out where the atoms are. So here we have the atom that we want to move. Here we have our needle. And we switch between the imaging mode, where I stay relatively far away, to the moving mode, where I get close in. And now these 2 atoms are so close that they chemically react with each other. And so then we can drag this atom along the surface and position it to a new location. Here you are actually in the microscope room. This is the room where the actual tip is, where the sample is, where the action is taking place. We're working at a temperature of minus 260-something degrees centigrade. We do this so that these atoms hold still. When we're moving atoms in the laboratory, you'll actually hear a noise.
Now the sound you hear is the sound of the molecule following the tip along the surface.
For us, hearing this scratchy sound is important feedback because we can count how many positions have you actually moved. You go, and you can say, all right, this was 3 locations. Now, of course, we usually build things that can do computation data storage. In this case, we're just telling a very simple story of a boy named Adam falling in love with an atom, dancing together, playing together.
I think it's very exciting to be able to share something that I really love. Maybe it helps other people be fascinated just by the size of atoms.
If I can do this by making a movie and I can get 1,000 kids to join science rather than go into law school, I'd be super happy.
The ability to do something just because you find it interesting is a really important thing, particularly for research, because that's how you stumble across things that are new.
Now, we can't know in detail what those future technologies will be, but we can lay the scientific groundwork for them, and we can spur our own imaginations and get a head start in exploring these new worlds.